Right, we are now on question number 9. It reads, the diagram shows a graph of y is equals to f of x. On separate diagrams, sketch the graphs showing clearly the coordinates of the marked points. Right, so what is the meaning of y is equals to 2 f of x, which is the first part? They want you to sketch the graph of y is equals to 2 f of x to get the 2 marks. So it is very simple. This is a stretch, right? This is a stretch along y-axis. Along positive y-axis direction. All right, so if you have a number which multiplies f of x, we have a stretch. So stretch is usually denoted by this multiplication. We have 2, which is multiplying f of x. So it's a stretch along y-axis direction. And the stretch factor is 2 itself. I hope you are following. All right. But if you have y is equals to f of 2x, where the 2 is inside the bracket, yes, it is a stretch, but it is a stretch along positive x direction. And the stretch factor is not 2, but it becomes the reciprocal of 2, which is half. I hope you are following. So if the multiplication takes place inside the bracket, it's a stretch along x-axis. But if the multiplication takes place outside the bracket, it's a stretch along the y-axis. Then for x-axis, the number 2 is not taken as it is, but the stretch factor is the reciprocal of 2, which is half. Then for y-axis, you take the number as it is. So in this case, we have a stretch which is along positive y direction, and the stretch factor is 2, since the multiplication is taking place outside the bracket. So what is the meaning of stretch along y-axis? It means multiply all y coordinates by 2, whilst x coordinates remain the same. So you can clearly notice that the original point A is minus 2, 0. The original point B is minus 1 and 8. The original point C, we have 0 and 4. The original point D, we have 1 and 2, something like this. So all the values of y here are going to be multiplied by 2, which is our stretch factor, whilst the values of x remains the same. So here you get A1, B1, C1, and D1. A1, B1, C1, and D1. So the values of x are going to remain the same. So minus 2, minus 1, 0, and 1 are going to remain the same. But all the values of y are going to be multiplied by 2. So 2 times 0, you get 0. 2 times 8, it gives you 16. 2 times 4, you get 8. Then 2 times 2, you get 4. Then you plot your graph. So the first point is minus 1 and 16. Where 16 and minus 1 meets, there is a point. Let me mark it here. Right. Then another point, we have minus 2 and 0. This is minus 2 and 0. We have 0 and 8. 8 is between 0 and 16, so this is 0 and 8 here. 0 and 8. Then we have 1 and 4. So this is 0 and 8. 1 and 4 is here. All right. I hope you are following. So let us plot the curve. So if we plot, it comes out like this, like this. So this is y is equals to 2 f of x. I hope you are following. So do not forget to label. So this is A1, B1, C1, and D1. I hope you are following. So let us move on to the next. Here you have y is equals to f of x minus 3. So for a negative sign and a positive sign, we refer to it as translation. But for multiplication, it is stretch. I hope you are following. Unless if we have a negative f of x, this one, it's now reflection, where x-axis is the mirror line. Right? But any number like 4, it's stretch. Right? So we are having y is equals to f of x minus 3. We need to identify the transformation first so as to map the original graph to the image. Here, you can notice there is translation, but the addition or the subtraction is taking place inside the bracket. So it's translation along x-axis. It's translation along x-axis direction. So for translation, you attach what you call translation vector. You need to attach a translation vector. So here, if you have minus 3, you take minus 3 as you put 3 here, then you put 0 below. I hope you are following. But if you have f of x minus 3, you can notice the subtraction is taking place outside the bracket. So for this situation, it's a translation along y axis. Then the vector becomes 0 and minus 3. So it means for y translation vector, you take minus 3 as it is. But for x, if you have minus 3, you take it as 3. I hope you are following. So do not forget that we have the original values. A is minus 2 and 0. B is minus 1 and 8, right? C is 0 and 4, whereas D is 1 and 2, something like this. So what is the meaning of translation with the vector 3? It means all the x coordinates are going to be added by 3, whilst the y coordinates remains the same. So these are the x coordinates here on the left. They are going to be added by 3, but the y are going to remain the same. So you get A1, B1, C1, and D1. I hope you are following, class. So the y are going to come out as it is. Paste and copy them as it is. They are not going to change. But I'm going to add the x coordinates by 3. So minus 2 plus 3, positive 1. Then 3 minus 1 plus 3, you get 2. Then 0 plus 3, you get 3. 1 plus 3, you get 4. This is 1, 0. Then we need 2, 8. So this is 2. And this is 8. This is 2, 8 here. Then we need 3, 4. This is 3. 4 is between here. So 3 and 4, they are meeting here. Then we have 4 and 2. So this is 4. And this is 2 here. They are meeting here. So if we plot our graph, it comes out. Remember, for translation, it maintains the original sitting position. So it means we are going to draw it like this, like this, like this, like this. So you just need to maintain the original shape, sitting position of the shape. So it comes out like this. Do not forget to label A1, B1, C1, and D1. So this is f of x minus 3. Part C, it reads y is equals to f of minus x. This is a reflection. We refer to this as a reflection. But since the negative x is inside the bracket, it means your mirror line is y-axis. I hope you are following. But if you have minus f of x, it is a reflection, but your mirror line becomes x axis. So this is reflection, mirror line y-axis. This is reflection, mirror line x-axis. So we are going to reflect all these points here with y-axis as our mirror line. I hope you are following. So the first point is A is equals to minus 2, 0. I hope you are following. So if this point is reflected by y-axis, you get 2, 0. 2, 0 becomes your A1. Right, good. Then if we reflect this point, this is minus 1 and 8. It comes here, you get 1 and 8. So here it's 1 and 8. This is B1. Then if we reflect C with y-axis, since C is on the mirror line itself, it remains the same. It is an invariant point, 0 and 4. So 0 and 4, C1 is going to remain the same. Then if we reflect D, you have negative 1 and 2. So we need to put negative 1 and 2. This is your D1. So if we plot, your graph comes out like this. Comes out like this. Like this. So this is y, f of minus x. So this is your A1, B1, C1, and D1. So D1 is minus 1 and 2. C1 remains the same. Since it is on the mirror line, it is an invariant point. Then you are warm and dry.